Yeah, how do you make sure that your rotary tables do not overheat?
Well, it's one of the most important factor here in DD rotary table. So we use, as you see here in the table, we use a KTY silicon sensor.
KTY sensor?
Oh, yeah,
okay.
we have it embedded inside the DD rotary table. And it's also a BTC kind.
PTC.
A positive temperature coefficient.
All right, all right.
Yeah, which means in simple words, the resistance of the sensor has to be proportional to the current temperature.
Okay, got it. Now, the sensor, of course, does not directly adjust the temperature, but it's very important for temperature control. So, Sam, how exactly does this sensor help prevent your rotary tables from overheating?
Well, in simple words, the sensor will just send a feedback of the temperature to the controller, and the controller can stop the motor at any specific temperature.
Okay, so that's how it works, but I'm sure you also have to test that, right? So
absolutely.
you must follow some kind of procedure as well there?
Of course, yes. Thank you for reminding me of that. We tested according to NEMA, the Electric Manufacturing Associations, yes.
Okay, so that's NEMA, but installation class F. Maybe you can explain that.
Now we're getting even more technical. Okay, well, it means in an environment of 40 Celsius, the allowable equilibrium.
So an environment like here feels like it.
Yeah, it's kind of, yeah.
Okay, 40 degrees Celsius.
40 degrees Celsius, the allowable equilibrium of the rated torque increases and should be less than 105.
Okay.
And in order to reach that kind of equilibrium, I mean the temperature equilibrium, we should run the rotary table for 3 hours.
For 3 hours? Wow, that's a long time. Why exactly? Why 3 hours?
Well, because during the first 30 minutes, the DD rotary table temperature rises rapidly, then start to become stable. When I say stable, I mean the temperature starts rising 1 Celsius per 30 minutes.
Okay.
Yes.
So after 3 hours, it's reached the peak most of the time?
We can say so, yes.
Okay, so now let's see if I have understood what Sam has just been telling us. So if we have a surrounding temperature of, let's say, 30 degrees Celsius, and then on top of that we add the 105 degrees that you were just talking about, then we would have an equilibrium.
135?
135 degrees,
yes,
is that correct?
Correct, absolutely, yes.
Yes, 100 points for me, all right. But 135 degrees Celsius, that's how hot the motor gets inside your rotary tables. I wouldn't have expected that, it's so high.
Well, it's very common when it comes to the DD rotary table. As I mentioned before, during the rated torque, the DD rotary table operates continuously. So we use a robust sensor to avoid the DD rotary table from getting overheated and burning out the coil. And this is how we define the torque.
Okay, got it. So that's the built-in KTY sensor, monitoring the temperature and obviously sending out signals about the current temperature level.
Of course.
But you must also have some kind of system in place, Sam, that with which you can reduce the temperature and keep it low or below a certain threshold,
yes,
right?
Of course, yes. In simple word, we have to use a water cooling system, right?
Okay, a water cooling system.
Yes.
Now, you talked about some of the most important components of a rotary table.
Yep.
And that water cooling system, it runs through all those parts, all those components?
Well, no, not that simple. The DD rotary table operates through the interaction between the stator and the rotor.
I remember from our last episode.
Previous episode, yes. So the stator and the rotor create a magnetic field and an electric current inside the coil to generate a torque in the form of rotating rotors. So the highest temperature and the power generated from these parts.
Okay.
So we have to design a circumferential water cooling on a workpiece, which is called a water jacket. Then we have to assemble the water jacket on the stator. Yes.
And that's basically how the water cooling system is structured.
Absolutely,
and where
yes.
most heat dissipates from.
Sure, of course.
All right, so I think we've covered this whole area: temperature control, heat generation, cooling. And